Hello everyone and welcome to this tutorial. In previous tutorial we have started data pre-processing. First we have imported the libraries and dataset. After that we have done some data exploration. Then we have dealt with missing value. Now we have to encode the categorical data. Copy this line. Paste. So here we are selecting the columns with categorical data. So these are the three columns with categorical data: sex, smoker and region. Let us check the unique values as well. Data set, column name, and then function unique and execute. So there are two unique values in this column: sex, female and male. Now copy this line, paste again, check for the smoker. Yes, no. Here also same, two categorical values. Let us check for the region. So there are four unique values in this column: region, southwest, southeast, northwest, northeast. Let us check the dataset again. Dataset dot head. So this is our dataset. There are total three categorical columns and we have to encode all these three categorical columns. To do that, we will use one hot encoding. Type pd dot get dummies and in parentheses specify the data. We will specify entire dataset. After specifying the entire dataset, the get dummies function will take all the columns which have categorical values and this will encode only categorical columns. We have to specify one more argument here. Drop first is equal to true. This will drop the first column after one hot encoding, and this is to avoid the overfitting. Redefine dataset and execute. Now check the dataset again. Great. So you can see sex, smoker and region. So first column is sex underscore male. Sex is converted into sex underscore male. For female 0 and for the male 1. Let us check for the smoker column. This column smoker is converted into smoker underscore s. Yes means 1 and no means 0. So this is also successfully one hot encoded. Let us understand the region column. So there are total 4 categorical values in this column: region underscore northwest, region underscore southeast and region underscore southwest. 001 for the southwest, 010 for the southeast, 100 for northwest and 000 for the northeast. So here we have successfully encoded the categorical data. Let us check the shape for the dataset. 1338,9. So 1338 are the number of observations and number of columns is equal to 9. Let us move forward. Add a subsection. Correlation matrix. Now define one more variable. Dataset underscore 2 is equal to dataset dot drop. We have to drop this column charges. This is the target variable, so we are dropping this one and execute. Dataset underscore 2 dot correlation with dataset, specify the column charges. So here we are checking the correlation of independent variables with the dependent variable. Dot plot dot bar. Here we have to specify 4 arguments. First one is the figure size 16:9, then the title, correlation with charges, then the rotation 45°, and after that grid lines, grid is equal to true, and execute. Great. As you can see here, this column age is correlated with the charges. BMI is also correlated. These two, children and sex, are not much correlated. Smoker, this column, is highly correlated with the charges. Then these 3 columns are not so much correlated. So here we are getting some more insights about this dataset. Let us move forward. Define a variable dataset dot correlation. Now we have to draw the heat map of the correlation matrix. Type plt dot figure, specify the figure size 16:9, then SNS dot heat map, specify the variable that we have defined, and after that annotations is equal to true, and execute. Great. So this is the heat map of correlation matrix. So the lighter blocks are the more correlated ones. Here you can see charges and smoker. Same here, smoker and charges. Then charges and region southeast, also somewhat correlated, 0.074. Then this one 0.3, age and charges also. And this one BMI and southeast region. So this is all about the correlation matrix. Let us move forward. Now we have to split the dataset. Splitting the dataset. Now check the dataset. Before splitting the dataset, we have to specify X and Y. Matrix of features, or we can say that independent variables. X is equal to dataset dot drop. We have to drop only one column, this one, charges, and execute. So here we are selecting independent variables. All variables are the independent variables here except this one, charges. This is the target variable. Now let us define the target variable. Target, or we can say dependent variable, y is equal to dataset dot, not dot, we will select directly charges and execute. So here we have successfully defined matrix of features and target variable. Now we have to split the dataset. To get the reference, go to sklearn documentation, open in new tab, sklearn documentation, open the first link, go to API. Here we have to look for model selection. This one, model selection. And here we have to use this class train underscore test underscore split. Here we have description as well. Split arrays or matrices into random train and test subsets. Here we have all the details. We have to import this class from sklearn.modelSelection. I'll just copy this one. From sklearn.model selection, import train underscore test underscore split. And we have to specify 3 important arguments in this class. Let us see the examples. So this is how we have to split the dataset into train and test set. Copy this line, paste x train, x test, y train and y test. First we have to specify x, that is matrix of features, then y, this is dependent variable, then test size. I will specify 0.2, that is 20%, and random state is equal to 0. That's it. Now execute. Great. Let us check the shape. Xtrain dot shape and ytrain dot shape, then xtest dot shape and same ytest dot shape. So there are total 1070 observations in the training set and 268 observations in the test set. So using this class train test split, we have successfully splitted the data into training and test set. Let us move forward. Add one more section here. Now we have to do the feature scaling. Add few cells. To get the reference, go to official documentation of sklearn. Here we have to look for pre-processing. Here you can see pre-processing and normalization. And we have to use this class, this one, pre-processing dot standard scalar. It standardizes the features by removing the mean and scaling to unit variance. So this is the class that we are going to use, standard scalar, and we have to import this class from sklearn.preprocessing. Let us import this one from sklearn.preprocessing, then import standard scalar. And this is the formula for the feature scaling when we are using this class, standard scalar. Z is equal to x minus mu, and this is divided by s. Mu is the mean of training samples and s is the standard deviation. Now scroll down. Let us see the examples. So first we have to create an instance of this class like this one. Let us create an instance. We will call this instance as sc, and after that sc dot fit underscore transform method xtrain, redefine xtrain, copy this line, paste xtest transform method only, that's it. So first we have imported this class standard scalar. After that we have created an instance of this class, and after creating the instance we are using this method fit underscore transform for the feature scaling xtrain and only transform method for the feature scaling of xtest. Now execute, check xtrain and xtest. Great. So here you can see we have successfully applied feature scaling on xtrain and xtest. You can see the range as well, -3 to +3. So here part 1, that is data pre-processing, ends. Let us revise what are the steps that we have performed in data pre-processing. Importing the libraries and dataset, data exploration, dealing with missing values and categorical values. Then we have drawn correlation matrix, and after that we have splitted the dataset into xtrain and xtest. And before that we have defined x and y, that is matrix of features and target variable. And at the end we have applied feature scaling. We apply feature scaling because we want all the independent variables on the same scale. So this is all about the data pre-processing. From the next tutorial, we will start to build the actual models. Till then, happy learning.